Okay, so yeah, this section, last period, my like 95 and higher A students were like, what the hell is going on? Okay, so fasten your seatbelts. Focus, focus, focus. What makes this section difficult is the fact that they throw every type of factoring at you in one section. Okay, so it's not nice that they do that. I'm not even going to teach you every method of factoring. But we'll get almost all of them. So we'll spend 2 days on this. You have a quiz at the end of tomorrow's class on this section, 5.3, okay? Ask Ayana, she'll tell you how nasty it was. It was like just savage. Yeah, okay? Right on top of those other ones is good. Okay, so you already know factoring the GCF, right? We've already done that. Factoring out the GCF. One type of factoring. Yep. Quadratics, right? When you have a leading coefficient, as we do here with the 6 in front of the x squared, that's where you have to do the full India method. Okay? So, Indian on this one. The hardest part is recognizing what you have to do when, right? Because that's a weird part of this. Perfect square trinomial. We talked about these as well. When we did completing the square, part of completing the square, you create a perfect square trinomial. You know you have a perfect square trinomial because I can square root the A and C term. That's how you know, okay? And it just makes it easier if you realize that. If you don't, you can still do the cross and in fact figure it out. It just takes a little more time. Sum and difference of squares. This example they gave right here is awful. This example is better. So if we just think about that, I can square root the A and the C term again, right? I'm missing the B term. The B term is 0. So square root of x squared is x. Square root of 4 is 2. So it's x minus 2 and x plus 2. Okay, if I have x squared minus 36, x plus 6, x minus 6. Those are the easy ones you pray you get in the homework because the other ones are just freaking nasty. So factor by grouping we won't get to today. We'll do that tomorrow at the beginning. And then it'll be like basically a work day tomorrow, just cranking through these problems. And then sum and difference of cubes, you want to write those down. I've also got them written bigger right up here. This is an example of part of the sum and difference of cubes problem right here. So that's kind of what happens. And I'll explain it more. So don't freak out yet. But you should freak out at some point. Because I know that makes you feel better. So write down the a cubed, b cubed ones. Those you'll have to memorize, okay? So a cubed plus b cubed equals a plus b, in parentheses, a squared minus ab plus b squared. So as you look at these formulas, right, you know I'm going to be a jerk now and make you memorize all these things. So you got to think like that when I introduce a new formula you haven't seen before. Maybe if you're an advanced Algebra 1, you've seen this formula before, but if you're in regular Algebra 1, you have not. That's not in our curriculum. But just to begin the path of memorizing these formulas for your brain, if it's a plus, they're cubes, right? A cubed, b cubed, that's why it's called the sum of cubes. It's a sum because it's plus. Simple as that. The first parenthesis, the sign matches what the problem is. In the second parenthesis, you just have a negative in front of the AB. Okay, if it's a difference of two cubes, like it is at the bottom here, right, we're going to have a minus in the parenthesis, matches that minus at the beginning, and then the next two in the trinomial parenthesis are both positive. Okay? So it's pretty easy to remember, right? We go from a cubed to a, we go from b cubed to b, right here in the parentheses. And then we take the a term and we square it to get a squared. Then we multiply the a and the b. And even though we get positive ab right here, because there's a negative in the formula, that negative holds true always. So it should be positive AB here, but because of the formula, it's negative AB. And then you take the B term and square it to get B squared. Okay, you don't worry about anything else yet, but that is the hardest example we'll do. So I'm going to do two of those examples, one with the sum, one with the difference of cubes. We'll do one at the beginning of the lesson and one at the end of the lesson. It'll just work out better that way. So many of you guys don't know numbers you can cube root. So you need to know how to cube root stuff on your calculator. So I'm just going to make up one of these sum and difference of cubes problems. So we'll do sum first. And I'll give you like the easiest problem I can possibly give you for this kind of problem. First thing, it's going to be sum of cubes. I'm going to write the formula down. And here's the problem I'm going to give you. Anyone know the cube root of 8? 2. So let's say you didn't know the cube root of 8. So cube root means same number multiplied together 3 times, right? 2 times 2 is 4, times 2 is 8. Cube root of 8 is 2. In the calculator, you should bust yours out. To do cube root of 8, we're going to hit math. And you see number 4 there is the little cube root. So math number 4. And then you just put an 8 in there and hit enter. Right, so if I want to do cube root of 125, I go math 4, 125, enter. Right, so that's how you do it, just math number 4. So if you need to write that down because you forget that kind of stuff with the calculator, to cube root, math number 4. Okay, so cube root of x cubed is x. Cube root of 8 is 2. So when you're dealing with problems like this, I always want you guys to get in this habit. And that habit is look at the highest exponent you have, which in this case is the 3 right here. That 3 means you should have 3 answers at the end. Because a lot of times you guys will forget one of those 3 answers. So when you look at the 3 at the beginning, you just remember I need 3 answers, okay? Because it's easy to miss one of the answers, and I'll show you why in a minute. Okay, so just building out that second parenthesis now. So I would go from a to a squared. So I go from x to x squared. Then I take what's in that first parenthesis and multiply together. So 2 times x, 2x. But that negative in the formula holds true. So even though when I multiply 2 and x, I get positive 2x, because there's a negative in the formula, it's negative 2x.
You wrote x squared.
Thank you. X squared at the beginning there, thank you. And then we take the b term, right, from the first parenthesis to the second, we square it. So we square 2, what do we get? 4. And then you look at that and you're like, oh, that's not that bad. Oh, just wait. We're just getting started. So now this parenthesis, the second parenthesis, will never factor. So you always have to do quadratic formula. A equals 1, B equals negative 2, C equals 4. And I'm going to rewrite quadratic formula, right? You too should rewrite it so you can remember it. X equals negative B over 2a plus or minus square root of b squared minus 4 times a times c. Right? You could even put that b in parentheses because you're going to have to use parentheses anyways. over 2a. So notice in that second fraction, the radical is in the numerator only. Make sure your fraction bar goes all the way over so you know that square root is only in the numerator. Okay? Now we're going to plug in our values. Always on these problems, you're going to end up with a negative square root that you need to simplify into imaginary. So we bring back that concept from chapter 4 of imaginary numbers now, right? So what's tough about this topic is they throw all these factoring methods at you at once, so you need to be able to look at the problem and know what to do. And then you also have to remember stuff from the previous chapter. That's like a recipe for difficult section in this Algebra 2. Okay, so we get x equals 2 divided by 2 is 1, plus or minus square roots. 4 minus 16 is negative 12. So remember, you guys, what I like for you guys to do is take the entire underneath the parenthesis part and throw that into your graphing calculator so you don't make any careless errors, because it's obviously easy to make careless errors on this problem. We got to break apart square root of negative 12. So remember, in your calculator, you can hit the y equals. And just go 12 divided by x, and then look at your table by hitting second graph. And you want to look at this second column here. Biggest number I can evenly square root is 4. So when I break apart square root of 12, I break it into square root of 4, square root of negative 1, and square root of 3. So remember, this all started at x cubed plus 8. And it's just like exploding, this problem. It's not very nice, but that's how it goes. So 2i square root of 3, that's what I'm going to replace with square root of negative 12. Okay? So I like this technique of doing things off to the side here, because it's just easier to like separate it out, because the whole entirety of the problem will confuse you. But if you can separate things out and then plug them back in, it's generally easier. So 2i root 3 over 2. So the reason I've always had you make these two fractions, like one fraction here, one fraction over here, because oftentimes you can reduce both fractions, right? We already reduced 2 over 2 to get this 1. Now we also have to reduce these 2's, right, which are just going to go away. So we get x equals 1 plus or minus I root 3. That's it. How many answers is that? 2. Where's my other answer? Right, I started with cubed. You guys tell me. Look at the original thing. What's my third answer? From the parenthesis right here, right? So we take that x plus 2, set it equal to 0, subtract the 2 over, it's going to be negative 2. So all the way back, right? Because you get lost along the way. You're cranking away through quadratic, like I feel good, I'm doing it right, and then you forget that third answer and I take a point off, and that's when you want to murder me. So I like my life, don't murder me. So we take x plus 2, set it equal to 0. If you need to show that step, show it, it's totally fine. So that is my third answer, that negative 2. So the first, like, 3 or 4 of your homework are this kind of problem, okay? And then we go into different factoring stuff. Question, Trevor?
What exactly is the second answer?
So we have 1 plus I root 3, that's one answer, and 1 minus I root 3, that's the second answer, and then the negative 2. Okay? It's a good question because like clearing that up right away is super important, so you're not confused the entire time on these things. Okay. Break this one. Oh, question from Amanda, and then Maggie. What do you got, Amanda?
What was the first answer?
Well, we have 1 plus I root 3, that's one answer. We have 1 minus I root 3, that's the second answer. And the third answer is the negative 2 we got from setting that first parenthesis equal to 0.
Oh, okay. Thank
Okay? Yep.
So are we going to have homework tonight and tomorrow, or just one?
You're going to be working in class on your homework tomorrow, and then take the quiz at the end of class. And we'll definitely have one of these on that quiz, right? You know on the book, of course, right? And then we'll see what happens on the others. Okay, write this one down. So again, read the directions. Get in the habit of reading the directions. So many of you just crank through and you're like, hey, I'm doing math, I'm good. And you don't read the directions, then stuff goes wrong. So we have real and imaginary solutions. So you're always looking for that I. It won't always happen. That's why they say or. Either could happen or both. So when I solve this thing, first thing I got to do is get everything over to one side of the equal. So I'm just going to subtract that 3x. You get 2x cubed minus 5x squared minus 3x equals 0. So again, the hardest part of this section is recognizing what to do. So I look at this thing, tell me, what should I do? Take an x out, right? Everyone has an x, so I can factor an x out. It's a good start. And then I look at the numbers and I think, can I divide any number out? Nope. So I'm good. All I can divide out is that x. So we got 2x squared minus 5x minus 3 equals 0. So again, now we're at that recognition phase. So in the parentheses, what do I have to do? Indian method. I know I have to do the Indian method because I have that number in front of the x squared. So again, that's why we're pulling all this stuff I've taught you over the last couple of chapters into one section here, and you're like, wow, mind blown. So, Indian method, we're going to start with the cross. A times c up top, b on the bottom. So 2 times negative 3 is negative 6. Negative 5 is the b term. We have 6 and 1. It's got to be negative 6, positive 1. So again, if you need those factors of 6 so you can see them, some people will be like, it should be negative 2 and negative 3. Why should it not be negative 2 and negative 3? Because the 6 is negative, right? If I have both negative 2 and negative 3, I'd end up with positive 6, not negative 6. 6 is one of those ones that like messes with people epically. So just make sure you multiply and add them together, the sides of your cross, because you got to multiply to the top and add to the bottom. Okay? That's worth emphasizing. Multiply to the top, add to the bottom. Do both to check. Because there are certain ones I can do to you which will mess you up. Like if I do x squared plus 10x plus 24, because 24, 12 and 2, I can get to 10. 6 and 4, I can also get to 10. Right? 6 and 1, I can get to 5. 2 and 3, I can get to 5. That's what makes those different numbers more challenging. Because there are two ways to get to the same number. So that's why you need to check both multiplication and addition. Okay, next thing we do is we take that a term. That becomes the numerator of 2 factors. Sides of the cross become the denominators. And remember, we're always using that concept. The highest degree we had in the original problem was 3. So we're looking for those 3 answers. Because we're only going to get 2 answers here. So you also have to remember this x we factored out at the beginning, that's going to be x equals 0. That's going to be our third answer. And it's just easier to forget that, so just be careful like always. 2 over negative 6 reduces to 1 and negative 3. The 2 and the x always cancel. I'm just going to I'm not going to make the parentheses. I'm just going to automatically make them equal 0 so I can skip a step. So I get x minus 3 equals 0. I get 2x plus 1 equals 0. And then we're just solving for x, like normal. So here's one answer. Here's my second answer. My third answer is from that x equals 0. Third answer right there. So it's always when you guys factor out that monomial, like it's guaranteed 15% of you will forget about that monomial you factored out. So again, that double check is looking at the original problem, highest exponent, that's how many solutions you should have. Realize sometimes the solutions repeat. If we factor out an x squared, that means 2 of those are zeros, right? Because x squared equals 0, you got 2 zeros. So that can happen too. It'll happen on the next problem, as a matter of fact. So there are your 3 solutions. So this one, we factored out a GCF, and then you look at the parentheses, you have a number in front of the x squared. That's what tells you you got to do the Indian method, this piece right here. Okay? Write this one down. First thing I got to do is subtract that 6x cubed over. When I do that, I get 3x to the 4th minus 6x cubed plus 12x squared equals 0. So I'm always writing those in standard form, right? Highest exponent, next highest, and so on. What's the GCF here? 3x squared. Excellent. Divide out that 3x squared. Anytime I factor out a monomial, that's what we're doing. It's always going to equal 0. This time, because of this squared, I'm going to have 2 zeros. Okay? So that's 2 of my 4 answers. So that's right. We'll get 3x squared. First fraction, all we have left is x squared. Second fraction, minus 2x. Third fraction, plus 4. Yep.
Oh, never mind.
You good? Okay. It's good to ask. You answer your own question. That makes it easier on me. Okay, when I look at this parenthesis, and if I think about the old cross, can I get the sides? That's when you're like, oh crap, it doesn't work. What do you do when it doesn't work? Well, how do you solve a quadratic that does not factor? Begins with a Q. Quick. Quadratic formula, okay? Or complete the square. For me, I would always complete the square because I think it's easier. And you're going to do plenty of quadratic formula. The only reason I'm going to complete the square on this one is because I've got an even b term. If you have an odd b term, don't complete the square. It's just nasty. No need. So we're going to complete the square right here. It's good for me to remind you of this as well. Like this is a technique, you always want to make it look like this. Where you've got that blank space after the B term, you move the C term to the right side of the equal, and then you have the blank space after the C term. We always do the B over 2 squared thing, and I'll let you guys get caught up. I would definitely write that you're completing the square here, so you just remember what this method is called, because it's easy to forget, especially when they throw like 12 factoring methods at you in one section. So we get negative 2 over 2 squared, which is negative 1 squared, which is positive 1. So I'm going to take that positive 1, and that's going to go, I didn't write the beginning of this, x squared minus 2x, blank space, equals negative 4, blank space, sorry, I forgot that part. And then I'm going to put the plus 1 in my two blank spaces.
Wait, why did you number 4 over?
Right.
Like you subtracted 4.
Because you got to have the C term on the right side of the equal. So we just created a perfect square trinomial on the left side of this thing because I can square root the A and the C term. When I square root the A and the C term, square root of x squared is x, square root of 1 is 1. You always take the sign in this parenthesis from the B term. So it's x minus 1 squared. And then negative 4 plus 1, negative 3. Now you can do quadratic formula, you'll get the same answer. It's fine. If you don't like completing the square, you should, because it's easier than quadratic, but, you know, whatever works. So last step of completing the square, or not last, but close to, I square root both sides. I get x minus 1 equals plus or minus square root of negative 3. Add the 1 to both sides. So we get x equals 1 plus or minus. I got to simplify square root of negative 3. So again, I'm going off to the side. Square root of negative 1, square root of 3, I square root of 3. That's where this section kills you guys. Because it's like, I thought I was good, and then you got to do one other little thing off to the side, and that's when you start to think bad things about me. It's okay, I can take it. So how many answers do I have? 2. How many should I have? 4. So your other 2 answers are from that 3x squared we factored out at the beginning. Right, if I set that equal to 0, x squared equals 0, square root, x equals, it's technically 2 zeros. You don't have to write 2 zeros, I don't care if you do or don't. I'll know you know what you're doing when I see that x square root over the x squared is a 0. So I'm just going to write 2 zeros because, you know, why not? Because it kind of looks like a face at the end.
Yeah.
With the little nose, right? Oh yeah. This is 2 slides, this one. So we divide out that 3x squared, right? That's where those 2 zeros came from. So you think about this section, right? And I see pain to look at on some people's faces, like, oh my God, what the hell is going on? Here's one problem. Nice, easy, short, just flows right off your mind, right? And then we go to the next example. Here we go, factor to GCF. And then you're like, thank God, we only had to do the Indian method? That's so nice. Whereas before, you guys would be like, really? You're making me do Indian method? Well, now that's the easy part. And then we look at this one, and you're like, oh, crap, I can't factor that parenthesis. What do? Quadratic formula or complete the square. So there we go. Just the fun keeps on coming, right? Good times. Okay, these are the easy ones. As soon as you see the 4 right up here, the 2 right here, and then just the number, you're like, thank God. Of course, there's another little wrinkle to it, but it's still not that bad. This is by far the easiest one. And these are the last, like, 4 or 5 problems on your homework this time. Always, I got to get everything to one side, right? So as soon as you see real or imaginary keyword being solutions, that's where you have to make it equal 0. Because it says solutions, it's got to equal 0. So I'm going to subtract this 4 over. So I get x to the 4th minus 3x squared minus 4 equals 0. So your recognition piece, because that's the hardest part of this whole section, the recognition, your recognition is seeing that it goes 4, 2, and just a number for the last thing. There's no variable there. That tells you you can use this method. So we're just going to factor it like normal. So the only difference between factoring this thing and factoring your regular one, you have x at the beginning of the parenthesis. This one, we're just going to have x squared at the beginning of the parenthesis, so it's not that big a deal. So negative 4 up top, negative 3 on the bottom, got to be 4 and 1. So when the top is negative, the bottom is negative, the bigger factor has to be negative. These are the things I told you when I first taught you this. I'd say like over and over and over again. If when I say that, top negative, bottom negative, bigger number negative, that helps you, great. If it doesn't, don't even worry about it. It's fine. You can still get the right answer. So my 2 parentheses then are x squared minus 4. And I say 2 parentheses and then I don't write a parenthesis because I'm skipping the steps. So I can just set it equal to 0. And then x squared plus 1 equals 0.
Where did the x squared come from?
Because you just have to know.
You just have to know.
Because it's x to the 4th,
Yeah.
think of it like square rooting that. So I'm just going to cut the exponent in half. So that's why it's x squared at the beginning.
Is that one of those things where we don't need to just do it?
I mean, technically, if we box this thing again, right, we'd multiply that first upper leftmost box and get x to the 4th. So it's always going to work out like that. So that's why I don't emphasize it that much. You just see the 4 and you know you're going to have x squared down here and don't even worry about it. Okay? It's easier that way. When I was an Algebra 2 student, I'm like, just tell me how to do the freaking problem and I'll be able to do it. So hopefully that mentality works for some of you as well. We're going to have 4 minus 1. As soon as you see a negative on the right side, you know you're going to have imaginary. Like right there, I have negative 1 on the right side, so I know I'm going to have imaginary. So like the 4th different kind of factoring we're doing now, right? It just gets weird. Square root both sides, don't forget plus minus. First one's easy, square root of 4 is 2, x equals plus or minus 2. What's the square root of negative 1 equal? I. So plus or minus I. That's my 4 answers. Plus or minus 2 is 2 of the 4 answers. Plus or minus I is the 3rd and 4th answer. Okay? So that's why that's a lot shorter than the other problems, right? You pray you get these because they're not nearly as bad. Try this one on your own. Now there's no B term, so let me just show you what the cross is going to be. So this is the sum or difference of 2 squares, because the square root of x to the 4th is x squared. square root of 16 is 4. Make sure you subtract that 16 over, first step. Go all the way till you're square rooting the x squared at the end there. And your answer, no, that's not true. I'll tell you the answer. There are definitely probably at least 10 students in here that could do this problem in their head. Yeah, just think about that. Like if you know you're one of those kind of students, try to think about it and do it in your head. You can do it. Right, I've been doing this for 15 years, so if I couldn't do it in my head, you should question me, but I can't. Alright, if you don't want to see the answer, you want to keep trying it on your own, go for it. I'm going to start doing it here. Don't forget about those eyes. So plus or minus 2i, because you got that square root of negative 4, right? You can break apart into square root of 4, square root of negative 1. That's where I got the 2 and the i. Square root of 4 is just 2. Again, make sure you got those 4 answers, right? X to the 4th at the beginning, plus or minus 2i, 2 to the 4th, plus or minus 2, 3, 3rd, and 4th answer. It's good times. Yeah. Just wait till you start to do the homework. Alright, I'm going to make this harder. Write that formula down again. This is the last one we're going to do. Let me make sure. Yeah. Last one we're going to do. You're going to do 8x cubed. So when you throw a number in front of that first x cubed, don't freak out. It's all going to work out. I guess you can freak out. But it's like when I made that comment about, like, you know when you have those negative thought cycles and they just keep going, like how often does that help? Never. So stop doing it, right? So this one, we're going to cube root. What's the cube root of 8? 2. What's the cube root of x cubed? X. So a here is going to equal 2x. Cube root of 8 is 2. Cube root of x cubed is x. Cube root of 27? 3. Again, if you forget, right, you go math, number 4. No, I don't want to do it that way. Math, number 4. Throw in your 27. Enter. 3. So, minus 3. So now if we go from a to a squared, a is 2x. So if we're going 2x and we're squaring it, you have to square both parts, both the 2 and the x, so you get 4x squared. Okay, the middle term, we're multiplying the 3 times the 2x, ignoring the sign. So plus, because that plus in the parentheses, plus 6x.
Which
2 times 3. Right there. It's okay, like, ask all of those questions, because it'll seem like I'm pulling stuff out of places you didn't want to see me pull stuff out of. Alright? So 3 squared is 9. So don't write 3 squared here, just write 9. Right? So b is 3. 3 squared is 9. That's why I wrote the 9. You always have to do quadratic. So celebrate quadratic time. You will always end up with an imaginary number under the square root on these problems, so just anticipate. Don't forget about the 2x minus 3. If you want to set that equal to 0 right at the beginning, because you know you might forget it, do it right at the beginning. That's fine. I'm going to wait till the end. I remember, because I have a cube, I have those 3 solutions that works for me to remember the third solution. So I'll do quadratic first and then set 2x minus 3 equal to 0 later. So quadratic, I was like writing the formula, because then I know where to plug stuff in. Just take your time with this. Like, don't rush through it, because you're going to screw it up if you do.
Why is b negative 6?
Why is b negative 6? Because it's negative b. 6 is positive, or b is positive 6, so I got to make it negative 6.
I'm looking at the wrong number.
Okay, no problem. Yeah, always ask. So, underneath a radical, I always like when you guys take what's underneath a radical and put that into your graphing calculator. So I know, because I'm a math teacher, 16 times 9 is 144, 36 minus 144 is 108, is that right? Yeah? Okay. That's just my little math teacher brain, don't worry. 6 divided by 8 reduces to 3/4. So just to remind you, you can do that in your calculator, right? 6 divided by 8, math, enter, enter. Because one of your homework problems, you're going to be reducing 15 over 50. And most of you don't know that's 3/10. So do that calculator thing, right? Just divide it and math, enter, enter is how you do it. So just divide the 2 numbers, hit math, enter, enter to reduce a fraction. Okay, so negative 3/4 plus or minus square root, negative 108. See, this is my little math teacher brain. That's 6i root 3.
What?
You got that, right? Yeah,
Oh, yeah.
totally. So, how did I do that? You can think about hitting your y equals and doing 108 divided by x. Now we want to look at the factors. And I want to think about factors from this column that I can square root. I can square root 36. So 3 and 36. So when I look at 108, negative 108, off to the side, I want to do square root of 36, square root of negative 1, square root of 3. So see, even like the problems just keep, they just blow up, right? It's kind of annoying, but you'll get over it. Or you won't. So that square root of negative 108 turns into 6i root 3. So we're still going. So the reason I've always had you make those 2 fractions with quadratic formula and not write the big fraction bar is because oftentimes we can reduce both fractions. So this is one of those times when you can. So it becomes 3 and 4, like that. So, and now is when you should be questioning your life choices about being in Mr. Evans' Algebra 2 class, right? It's like, why? Why? How many answers is that?
2.
How many do I need?
3.
Oh, yeah. So we have that 2x minus 3, that first parenthesis we did at the beginning. That's our third answer. And the good time was had by all. Or not. So, it's a little nasty, right? You got the rest of the time to work on your homework. The only one, when I put up homework, you're going to skip 14. That's the only thing that we didn't get to, because that's what we're not. We're going to do factor by grouping tomorrow. So this, the only addition to this is we're going to say skip 14, because that's the factor by grouping one. You learned how to do that freshman year. If you remember how to do it and want to just get it out of the way, because you're going to have to do one anyways, get it out of the way. If you don't want to do it, don't do it. It's totally fine. All right. The homework is posted already.